Hey guys, welcome to day 78 of Codeforces Every Day until GM. I've recently started posting a few, I guess, I would call them higher quality videos, where I go over problems that I had trouble on, and like thoroughly understand them and explain how to do them, like the intuition, the thought process, the different parts you need to know, and how to code up the solution. Um, they are I don't know. Tell me if y'all like them. Tell me if you want more of those kinds of content where it's a little bit more educational than me just doing problems. Or you just want to see me do more problems, or like what other types of content can I put out for y'all guys? I do want to try to up the quality a little bit. Maybe do a little more editing, you make some thumbnails, stuff like that. I don't know. I'm not really good at YouTube, but yeah, let me know in the comments. There was one really nice viewer who suggested some stuff, and I'm thinking about it. So yeah, with that out of the way, let's get straight into solving problems. We were both children. We're doing a little bit harder question today. For the past few weeks, we've been doing 1200. But I was like, why not try 1300 today, you know? Gotta push myself eventually. Can't always stay in the realm of mild discomfort. Because I feel like that's where I am these days. I need to push myself to do better. Or I'm not going to get any better. So, yeah. Mihail and... Oh, it's an I. Mihai and Slavic were looking at a group of N frogs numbered from 1 to N, all initially located at point 0. Frog I has a hop length of AI. Each second, frog I hops AI units forward. Before any frogs start hopping, Slavic and Mihai can place exactly one trap in a coordinate in order to catch all frogs that will ever pass through the corresponding coordinate. However, the children can't go far away from their home, so they can only place a trap in the first N points, that is, in a point with a coordinate between 1 and N. And the children can't place a trap in point 0 since they are scared of frogs. Can you help Slavic and Mihai find out what is the maximum number of frogs they can catch using a trap? Alright. First line of input contains a single integer t. T equals int input. And then like in range t, what do we do? N equals int input. And then we take in an array, a equals list map int input split. For each test case, output a single integer, the maximum number of frogs Slavic and Mihai can catch using a trap. Okay, so each second, frog I hops AI units forward. Before any frogs start hopping, Slavic and Mihai can place exactly one trap in a coordinate in order to catch all frogs that will ever pass through the corresponding coordinate. However, the children can't go far away from their home, so they can only place a trap in the first N points. And okay. Frog I has a hop length AI. Each second frog I hops AI forward, they can put a trap. I'll catch all frogs. Okay. Okay, maximize the frogs. Okay, so basically frogs are hopping towards them. They're allowed to place a trap anywhere from like 1 to N, and the frogs each have their own hop length, and we want to maximize the number of frogs to catch. Okay, this seems like just a math thing. I feel like my intuition says math. I don't really see much like what can I use here specifically? I'm also thinking maybe like no, sorting is not going to be useful. Uh, it seems like it's just going to be a math question. Yeah, brute force implementation math number theory. What makes this question difficult though? It's 1300 for a reason, right? In the first test case, frog 1 hops 1 step, so 1, 2, 3, 4. Frog 2 hops 2 steps, so 0, 2, 4. Frog 3 will never be caught. Frog 4 will be caught, and then frog 5 will never be caught, so the answer is 3. Alright. What is in? The number of... Okay. All at point 0 can place exactly one trap in a coordinate. I see. So it's like all frogs are here, and we have to place a trap somewhere here to catch as many as possible. GCD? No, it's LCM. Less than in. Right, we can only place a trap from 1 to n. Yeah. So most common multiple below 5. It's 5. Is this a modulus question? And what's my time complexity? 3 seconds, 2 times 10 to the 5th. 10 to the 5th is quite small. 10 to the 9. Are we allowed n squared solution? This seems pretty simple. Thinking of like division, double divide. N divided by hop, n double divide by hop, and then we count. Oh, it's modulus, right? It's a modulus question. We store the modulus in a map, and whoever has the greatest wins, I think. This reminds me of one question. Okay, so for a map equals this. For I in A, for n in A mod equals let me think about this. Five mod 2 is 1. 5 mod 4 is 1. 5 mod 1. Wait. Five mod 1 is 0. Is it mod or is it double divide? Or is it... Huh. Well, one can be anything. Okay, let's look at a few different cases before I start implementing. Case 6 here, or 3 here. 1, 2, 3 is 3 because 3, 3, 9. Alright, we can pick 9. Wait, what is in? We can only choose 1, 2, and we can never catch 10, right? There's frogs we can never catch. We can't catch 9 either. We can only catch 1 or 3, 1, 3. So mod 6 mod 3 is 0, 6 mod 1 is 0, 6 mod 3 is 0, and if this is greater than we... If n is greater than... Oh, for frog, if frog is greater than n, next case we get 5. 1 works for anything, so there's that. It's not specifically modulus, right? Because some numbers can work for multiple numbers. So, is it prime factorization? Is the answer prime factorization related? I'm starting to think it is. If we take each of the prime factors and increment it. I don't know if this is going to be fast enough. Yeah, right. It outputs it as an array. It's not. It's not. It's not mod. It's... How do we handle this? Is it prime factorization? Say we have an array Say we break everything down into their prime factors. It's a lot of numbers, though. There must be a math trick. Maybe this isn't right. How do I think about this? What's in 2 times 10 to the 5? Can I just iterate through all of them? N, it's O of n, and we just count divisible O of n squared. I mean, it's O of n squared. Like, we just iterate through. I don't know if this is stupid, but this is what I'm thinking. I think I iterate through the entire array. So for I in range in, let's start from stop -1. We don't stop at 0. We can add a better stopping point, right? Oh well. Let's not worry about time complexity for now. Let's just have something works. I'm thinking of behavior like this right now. It's not working. Why is it not working? Why do I get 5? Max frog is 0. We iterate I is 5. Frog is greater than I. Uh-oh. Did not mean to do that. Why is Riot Games opening? Frog is 1. Am I stupid? Frog should increment here. Y is 5. Oh, it's I mod frog. What the? Don't know why it's still outputting 5, but frogs. There we go. Bit of technical difficulties. Now, is this going to be too slow? This is n squared. I wonder if there's a breaking point I can use to where I don't have to. Well, let's just submit it and then we'll worry about it. Might just work. It's gonna TLE though. If this does work, I want to see the editorial. This is straight up brute force. Yeah, TLE. Okay, how can I make this faster? My first thought is I can set a better bound. My second thought is I have two loops inside of each other. Can I like incrementally build something? Still thinking about splitting everything into its divisors, and then one passing, or like counting up. No, it's not divisors. Okay, so first let's remove numbers outside of A from consideration. Next, this should filter my array, right? This should keep everything. This should filter out 10. Yes, this is over in operation. This is fine. I can also sort to achieve similar results if I want to. My answer has to be in login. Or O of n. Maybe there's an O of n solution. But I can't think of anything. If we iterate through, it's got to be modulus, right? The only thing I think about is modulus. But the thing is, 5 mod 1 is 0. As many frogs as possible. 2, 2. So, okay. It's gotta have something to do with primes. We start with 2. We check how many multiples of 2 there are. And we add a point. We start with 3. No. No, no, no. Uh, Still think it has something to do with prime factorization. So we have to iterate through the entire array. We pick some answer. Still think this is the best way. It's n squared. How can I make this faster? So what we're doing right now is we are checking if each is a divisor of k. I think it's a sieve. We have to use a sieve. But like, we don't need a sieve. It's like sieve style. Where's my sieve at? I think it's this. And we should keep track of contribution too, I think. So, okay, so duplicates. I need to check if I is less than or equal to n. Right. Can we increment? We check every number from 0 to n. Basically the same as this. Doesn't really matter where we start from, beginning or end, right? Start with beginning. If count I is greater than 0, then something is being contributed, which means we should iterate through 4 multiple in range from I to +1, increment by I, count multiple plus equals count I print max count. Right? Okay. Let me think. Yeah, so we count up the array, and then here we create a count array. That's how many times each number shows up. If they are greater than the number, if they're greater than n, we don't want them. Now we iterate from 1 to n plus 1, and if the count is greater than 0, then we increment its multiples up to, there should be n, plus 1. Because, yeah, each one contributes a certain amount, right? Isn't this n squared as well? It's not. It's n log n, because we're doing less computations each time. Right. Yes. Right. Okay, this should be n log n. Count the multiples. Yeah. Okay. Sure. I have an error somewhere. Uh. Count 0 array. This should be correct, right? Zero shows up 0 times. 1 shows up once, 2, 3, 4, 5. This is 2 shows up 3 times. 1 shows up once, 3, 2. But 1 shows up once, 2 shows up 0, 3 twice, 4 once. Yes, this is correct. Now what's incorrect is this part. So for I in range, if count I is greater than 0, count. I think we're outputting the value instead of index. Where's the question at? Oh, it's right here. Okay, how is there 18? What is this doing? Count is greater than, if count I is greater than 0. One three three nine 3. 0. This is fine. Count I is. Oh, is it this? Wait. Okay, this should be an array. Because I was overriding count. Yeah. 2 covers, 4, 6, 8, 3 covers, 6, 9. Yeah, I think this is correct. It took a little while though. Question F on a div 4. Last question F I did not take this long. Maybe it took this long. Maybe it took similar. Not sure. But I gotta go eat dinner. Hopefully this works so I don't have to debug it. Make it faster. Like if this TLEs, there's an O of N solution somewhere. Oh, we got it. Nice. Alrighty. If y'all enjoyed this video, be sure to like and subscribe. I will see y'all guys next time. Bye.